This is part 3 of our solving equations symbolically notes. This is multi-step equations with variables on both sides. This is going to go on page 50 in our math spiral notebook. Please write down multi-step equation, variable on both sides, and have that on page 50. Pause the video to do that. So our first equation is 1 plus 6x equals 15 plus 4x. This is like one of the Desmos hanger models we had yesterday where we have an x on both sides. I'm not going to draw the model, but what we need to do is we need to have x only on one side. So remember, these are our sides. We have a left side of the equal sign and a right side of the equal sign, and we don't want an x on both sides. We only want an x on one side in order to isolate the variable. So I have 4x that I'm going to take away from both sides, and I'm going to erase this. These are not division signs, these are underlines. So I'm going to minus 4x from both sides. If I have 4x's and I take away those 4x's, I'm left with 0 x's. And so I have 1 plus 2x equals 15. Now I'm exactly in my two-step equation notes. In my two-step equation notes, we said we wanted to isolate the variable. That's why we wanted to get rid of the x's on one side of the equal sign, so that now we can isolate it because there is only an x on one side. I'm going to minus 1 from both sides. 1 minus 1 is 0. That's what we want. We have 2x equals 14. If 2x's equal 14, I'm going to divide both sides by 2, and I get x equals 7. And now I'm going to check it. 1 plus 6 times 7 equals 15 plus 4 times 7. 1 plus 42 equals 15 plus 28. 1 plus 42 is 43, equals 15 plus 28 is 43, check. So my answer is x equals 7. On page 50 in your notes, please write down the equation, the steps, as well as the check. Pause the video to get all that written down. The next equation is 1 plus 2v equals v plus 9. Again, if I look at my two sides of the equal sign, I have a left side and a right side. I have a v on the left and a v on the right, and I only want a v on one side. It doesn't matter which v you get rid of. I'm going to get rid of just the regular v. Remember, if I have a violin and I take away a violin, my violins are gone. And I'm going to take away a violin from that side. We want to stay balanced. If I had only done it from this side would get lighter, this side would be heavier. 1 plus, just like in our last one, if I have two v's and I take away a v, that doesn't make 2. If I have 2 violins and I take away a violin, that leaves me with 1 violin, or 1 v, or just v, equals v minus v. That makes 0 because 1 of something minus 1 of something makes nothing. Now I need to isolate my variable. I need to get this 1v by itself. I'm going to subtract 1 off the end from both sides, and I'm left with 1v equals 9 minus 1, which is 8. Now 1v is the same as saying v equals 8. And now I'm going to check it. 1 plus 2 times 8 equals 8 plus 9. Multiplication comes before addition, so 1 plus 16 equals 8 plus 9 is 17. 17 equals 17. Check. So my answer is v equals 8. Please make sure you write down this on page 50 in your notes. We want to write down the problem, the steps, as well as the check. Pause the video and make sure you do that. Our next equation is x plus 3 equals negative 15 plus 4x. So if I look at my sides, my left side and my right side, again, I have a variable on both sides, and I don't want a variable on both sides. I want a variable only on one side. Now, a lot of you say, well, Ms. Gafour, is this combining? It's not combining if you're jumping over the equal sign. It's combining if they're on the same side of the equal sign. This time, I'm going to get rid of this x right here. So I'm going to minus x from both sides. X minus x, well, that's nothing, so I'm left with 3 equals negative 15 plus, again, 4 x's take away an x is not 4. 4 x's take away an x is 3x. Next, I need to get this 3x isolated all by itself on one side. I need to get rid of this negative 15. I'm at negative 15 and I want to get to 0, I'm going to add 15 to both sides. Again, this is just the basic two-step process. So 3 plus 15 is 18 equals a negative 15 and a positive 15 make nothing, and I bring down the 3x. Lastly, if I have 3 x's, I want to divide by 3 because this is multiplication, and the opposite of multiplication is division. 6 equals x. And now I check it. 6 plus 3 equals negative 15 plus 4 times 6. All right, this is 9 equals negative 15 plus 24. 25 minus 15 would be 10, so 9 equals 9. Check. All right, so my answer is x equals 6. Please write down question number 11 in your notebook, as well as the steps to solve and the check. Pause the video to make sure you get that done. Our last question has some negatives. I love me some negatives, but we're going to start the process the same way. I'm going to look at the left side and the right side. I have a p on the left and a p on the right, and I don't want them on each side. I only want a variable on one side. Doesn't matter which one you get rid of, but I'm going to get rid of the 2p. So I'm going to minus 2p from the right. I'm going to minus 2p from the left. When I do that, I'm left with this negative 6 plus 3p minus 2p is 1p equals negative 3, and the 2p's go away. I need to get this 1p by itself. In order to get rid of the negative 6, I need to get it to 0, so I'm going to add 6 to the left and add 6 to the right. Negative 6 plus 6 is 0. 1p equals negative 3 plus 6 is 3. 1p is the same as saying p, and that's still 3. Last, I'm going to check it. Negative 6 plus 3 times 3 equals negative 3 plus 2 times 3. All right, negative 6 plus 3 times 3 is 9 equals negative 3 plus 2 times 3 is 6. If I don't remember my integer rules, please take out a calculator. Negative 6 plus 9 is 3. Again, if I don't know my integer rules, take out a calculator. Negative 3 plus 6 is 3. Oops, check. That means my answer, oh, that's a lot of 3's, is 3. Please write down question number 12 in your notebook on page 50, as well as the check, and pause the video to make sure you have all of those components done. Thanks for finishing.